Flywheels launched like shrapnel, engine bays consumed by fire. 3 people drowned because a single bolt sheared at 4,500 RPM. Over 6 decades, certain marine engines have piled up body counts, bankruptcies, and repair bills past $20,000, and some are still powering boats for sale today. These are the worst power plants ever bolted to a hull, and the trail of failures starts further back than you'd expect. Chrysler's entry into the outboard market in 1965 promised affordable horsepower, but the reality quickly turned sour. Mechanics gave these engines the nickname dock ornaments for a reason. Persistent ignition failures and flawed carburetor setups left boats stranded more often than running. A service bulletin in 1977 warned dealers about overheating coils and unreliable spark, yet countless owners never received the fix. By 1979, a new single-jet carburetor design created its own headaches. Factory-set idle speeds were off by 15 RPM, causing rough starts and bogging at low throttle. Owners spent hours chasing elusive adjustments, only to find performance barely improved. The real blow landed in 1984, when Chrysler pulled the plug on marine parts and support. From that year forward, even basic repairs became nearly impossible. Engines that once seemed like bargains became permanent fixtures at the dock, abandoned by both the factory and the service network. For many, a cheap Chrysler outboard meant a boat that never left the slip again. Force outboards carried a hidden danger that went far beyond inconvenience. Inside the 150 horsepower models, engineers cut corners by machining the crank web fillet to just 0.12 inches, a cost-saving move that left the crankshaft vulnerable. When the crank fractured at this narrow radius, the heavy steel flywheel, spinning at up to 6,000 RPM, could shear off with explosive force. Between 1986 and 1994, at least 12 separate incidents were reported where the flywheel punched through the engine cowling and, in several cases, tore into the deck or cockpit. Owners described scenes where a 2-inch hole appeared in the transom or a chunk of metal landed inches from passengers. There were no official recalls, no service bulletins, and no warning from the manufacturer. Each time, the story ended the same way: a boat disabled, repairs impossible, and a near miss that could have been fatal. The silence from corporate offices sent a clear message: owners were on their own. MerCruiser's 3.7-liter inline-4 promised big block torque in a compact package, but what owners actually got was a masterclass in hidden costs. The engine block, borrowed from Ford's industrial lineup, was never designed for the relentless heat cycles of marine duty. Exhaust manifolds routinely hit 250 degrees Fahrenheit, hot enough to bake the alloy until it cracked. Once that happened, a simple day on the water could spiral into a blown head gasket or a coolant leak that left the boat dead in the water. The real pain set in at the repair shop. A full rebuild, including a new manifold and head gasket, could run $8,200, often more than the engine or even the boat was worth. Maintenance wasn't just expensive, it was nearly impossible. Parts were hard to find, access was tight, and even experienced mechanics dreaded working on these blocks. For many owners, the 3.7-liter wasn't just a money pit. It was a lesson in how the wrong engine can sink your wallet before your boat ever leaves the dock. GM's 4.3-liter Vortec V6 was a staple in trucks and SUVs, but once it landed in marine applications, the flaws became impossible to ignore. Unlike a true marine block, the Vortec used a single-pass cooling system, pulling raw lake or seawater through the engine in one direction. This shortcut left the hottest cylinders at the mercy of a 30% temperature gap from front to back, a difference that no automotive design ever had to handle. The result was a perfect recipe for hydrolock: overheated heads, blown gaskets, and water pouring into the cylinders. When the failure struck, owners faced a grim choice: A replacement long block ranged from $6,000 to $7,800, not counting labor or the inevitable hunt for rare marine-specific parts. Many learned the hard way that buying a car engine in a boat meant paying for repairs that never seemed to end. The lesson was simple. Automotive shortcuts on the water almost always end in disaster. OMC's Sea Drive arrived with the promise of innovation. But what owners got was a labyrinth of problems no mechanic wanted to touch. Rated at just 130 horsepower, the Sea Drive struggled to move even modest hulls, earning a reputation for being underpowered and unreliable. But the real nightmare began when it came time for service. The hybrid design forced boat owners to cut and reinforce their transoms just to mount the unit. A modification that often voided hull warranties and made reverting to a standard outboard nearly impossible. Dealers grew so frustrated with the Sea Drive's complexity and lack of parts support that many blacklisted the model entirely, refusing trade-ins or service appointments. Within a few years, lower unit failures reached 22%, double the industry average. Boats equipped with Sea Drive units saw their resale value drop by 18%, as word spread that even routine repairs could turn into multi-thousand-dollar ordeals. For many, buying a Sea Drive meant inheriting a boat that was both unsalvable and unfixable. Evinrude's FICHT direct injection system was supposed to save OMC, not destroy it. The company, a pillar of American boating since 1907, gambled everything on this high-pressure technology. By 1997, FICHT engines promised cleaner emissions and more power, but the reality was a relentless wave of clogged injectors and fuel system failures. Each injector ran at 250 bar, over 3,600 psi, yet the ceramic nozzles fractured, causing fuel to flood into the cylinders or spray back into the cowling. Fires broke out on the water. Owners reported detonations so violent it cracked engine blocks. The U.S. Coast Guard forced a recall of over 11,000 units in 2000, but by then the damage was done. Internal records revealed that 30% of all FICHT engines triggered warranty claims within a year, a rate no manufacturer could survive. The financial hemorrhage reached $112 million in new warranty expenses, pushing OMC into Chapter 11 bankruptcy that December. A century-old brand collapsed under the weight of a single, catastrophic design flaw. A fire hazard doesn't wait for warning lights or alarms. On Mercury's early Optimax outboards, a single rubber fuel seal, rated to withstand 120 degrees Celsius, became the weak link. When the engine compartment exceeded that threshold, the seal would soften and leak raw fuel directly onto the block. U.S. Coast Guard bulletins flagged these models after data showed that up to 30% of Optimax fire incidents were linked to this simple failure. The recall, designated U12, swept through dealer networks as mechanics scrambled to replace seals and check for hidden leaks. But Mercury wasn't alone. Volvo Penta's D3 diesel, praised for its lightweight design, suffered from aluminum fuel line connectors that corroded and cracked under vibration. Leaking diesel pooled in the bilge, just an exposed wire away from disaster. Both engines put boat owners in the crosshairs of a fire risk that could ignite in seconds, turning a pleasure cruise into an emergency. Saltwater doesn't just attack hulls, it infiltrates engines. And nowhere is the damage more punishing than with the MerCruiser 8.2-liter big block. Owners who thought they were buying unstoppable power soon faced a silent killer, riser corrosion. After just 2,000 hours, thin-wall stainless risers meant to route exhaust safely begin to rot from the inside, letting seawater slip into the cylinders. The result is hydrolock, a mechanical seizure that destroys pistons and rods in seconds. A single engine rebuild starts at $15,000 and can reach $24,800 for twin setups, often more than the resale value of the entire boat. The cost isn't limited to parts. Labor hours stack up as mechanics tear down massive blocks and chase hidden leaks. For owners, the MerCruiser 8.2L became a financial trap, one where a single wave of corrosion could wipe out years of savings and leave a boat permanently sidelined. Rotax's jet propulsion system for the Sea-Doo switch delivered a safety failure that no owner could ignore. At speeds above 4,500 revolutions per minute, the impeller bolt, critical for holding the jet drive together, was prone to shearing off without warning. This single bolt, overlooked in design, turned a modern family pontoon into a death trap. In 2022 and 2023, 3 separate drownings were linked to this defect: 2 adults lost in Maine and a toddler in Florida. When the bolt failed, the jet drive ejected its impeller, instantly disabling steering and propulsion. Boats spun out of control or stopped dead in the water, leaving passengers helpless. The fallout triggered Safety Bulletin 2023-31 and a recall covering 12,500 units. BRP, the manufacturer, faced a $20 million recall and settlement. The message was clear: even the latest marine engineering can end in tragedy if a single fastener is overlooked. Right now, thousands of boats still run on engines infamous for catastrophic failures and dangerous defects. Each new owner inherits the risk and the repair bills. In marine engineering, one overlooked flaw can sink more than a vessel. The warning stands: know what powers your escape or pay the price.